Talk about radicals. Better. All right, this should be a pretty simple lesson. I don't know if we're going to do videos at all the rest of the year. I will tell you, for those of you guys who are good on the videos, I'm going to record some of these and put them online. But, I mean, the thing that stinks about the videos, and this is the thing I don't think y'all understand, is that this video would probably take us about 20 minutes to do. You could have watched the video in 20 minutes, come into class, did the homework in about 20 minutes as well, and had the whole class to do nothing. So that's the only downfall. So we're going to do this as a normal class, and it's going to take a while to get through, I'm sure, because it has all. I mean, I haven't gotten, most people have not started on their homework today. So, I'm sorry? No. Okay, it's not that simple, of course. Okay, otherwise, I wouldn't stand up here and just say, oh, find 2 square roots and add them. It's not that simple. Okay? When we talk about radicals, we have a couple different types. We have a rational. And before we get into that, one of the things I want to tell you about with that activity y'all did yesterday. I'll borrow yours real quick, so let me check. This was not just some blow-off activity. I don't know if you did it or not did it. Obviously, Slovacek did hers. Okay? You're going to use this later today because it's going to make it helpful. I have my juniors do this as well to some extent. Maybe not, I don't have them do a foldable necessarily, but they do this because you're going to use this later and it's going to make your life easier having this. I know, yes, your calculator can do all of these things, but this little chart is going to make your life easier. Once you get this memorized, it's even going to be more easy. Okay? So you're going to need to have this out here in a little bit if you don't have it already. Okay? All right, the first thing we're going to talk about when we talk about rational is we're just going to talk about the basic, very simple radicals. When that means you're talking about something like this, square root of 9 is equal to 3. Square root of 64 is equal to 8. Square root of 121 is equal to 11. Okay, that's pretty basic. Those are perfect squares. Okay, or perfect square roots. You guys have those, or should have at least those 3 on your thing from yesterday. There are more than obviously the 25 that you did yesterday, but those are the basic. You can extend on this by saying, and this is example 2, what if I said negative square root of 36? What would that equal? Negative 6. So you square root 36, and then you get negative 6. Okay? You can continue to build upon that by saying square root of 16 plus the square root of 25. And what do you get? 9. 4 plus 5, right? Equals 9. You can go even further. Say the square root of 81 minus the square root of 4. And you get what?
7.
Okay. 9 minus 2 is 7. You could also do square root of 144 times the square root of 25, and you get 60. Or even the square root of 144 divided by the square root of 4. 6. Okay? And again, these are all the very basics. And I know that right now you're probably thinking, I already know how to do all this. This is the easy stuff. Okay? We're working our way up. I want to show you one more thing. You can also extend this and say, okay, square root of 256 squared. What's the square root of 256?
It would just be 256.
Okay, but what's the square root of 256?
Is it 16?
16. So now I have 16 squared is 256, as Trevor astutely pointed out earlier. Now, the thing I want to show you for this, okay, if you guys can't handle it, you're done. This is your warning, okay? The thing I want to show you for this is basically a square cancels out a square root, okay? So if I have a square here and a square root, they just cancel each other out. Oh, you can't see it. It's highlighted, sorry.
What if it had like 256?
Hang on. Don't start what ifing. I can't stand that. Okay?
Shut your mouth.
There you go. Okay, now what is your what if?
What if it had, or can it have like 256 squared and like have the square root thing over it? Can it have that?
What did
Yeah,
you
but it's
say?
the same
What is-
thing.
What cancels out right there? 256. What cancels out? 256.
The square and the square root cancel each other out. Okay? The reason I bring that up is because now, what if I just said, randomly I said, okay, well what about the square root of 6,342,301? Okay? Squared. Yeah, they're just going to cancel each other out, right? So then you have, like you were going to say, 6,342,301. Okay? Alright, so that's all pretty basic. Any questions so far? Alright. That's basically your rational roots, okay? Meaning that everything is perfect, everything is happy, everything is good. But then you have irrational.
Sounds pretty easy.
Now here's the deal. Can somebody tell me why we use fractions?
What does that say? IR rational?
Uh-huh.
What's that?
Irrational.
Irrational.
Can somebody tell me why we have fractions? Why do we use fractions?
Because not everything's a whole number, and you have to get those segments between whole numbers.
Okay, so why don't we use decimals? Why is it that I'm so adamant a lot of times on using fractions and not decimals?
Can go on and on forever.
Okay. Well, sometimes.
Decimals are pretty easy.
The truth is kind of like Trevor, building on what Trevor said, is the fractions can go on and on forever. So then what do we do?
They need decimals.
No, when a fraction goes on and on and on and on and on forever, what do we do?
How's a fraction go on and on forever?
Put a little line over it.
I'm sorry, I said fraction. I meant decimals. Excuse me. Decimals go on and on and on forever, so then what do you do?
Put a little line over it.
Say again? We round it. When we round a decimal, we have now approximated, meaning our answer is no longer exact. If we have a fraction, our answer is now exact. Okay? That is why we use fractions more than we use decimals. Okay? Because it is an exact answer. It's not approximated. Okay? Somebody tell me the exact number for pi. No. Yes, you can.
I mean,
No.
if you have a freaking 80 long piece.
No. It's infinity. No. That's infinite repeating. I mean, doesn't ever repeat anything.
Yeah, that's what I'm saying.
Okay? The exact answer for pi. What?
27 divided by 3.
No, close.
26 divided by 3. 28 divided by 3. 22 divided by 3.
22 divided by 7. Okay? Because it's a fraction. That is your exact answer for pi. So if anybody ever asks you what's pi exactly, and somebody says 3.14, you say, no, that's approximate. Because we round it off, right? You would say the exact answer is 22/7. Okay? Now, all that is tied into the fact that when we do radicals, we want the radicals the same way. If a radical is not perfect, we don't want to just put it in our calculator and get 3.725893116, whatever. Instead, we want to be able to simplify radicals so that we still have an exact answer. It's very similar to fractions. Okay, very similar to fractions, but a little bit easier. Okay, so let's look at our first example. Let's say I gave you square root of 27. Is that a perfect square? No. Pretty clear it's not a perfect square. Okay? So what I would have to do, and I'm going to show you kind of a longer method on the next two examples, and then I'm going to show you the easy method at the same time. So what I would have to do then is start to factor 27. So what are factors of 27?
9 and 3. 1
Okay.
and 27.
So then I essentially have 9, because that's what you said first, and 3. Now some teachers don't do it with the radical sign. I want to do it with the radical sign because what that radical sign tells you is that you have not simplified the radical out yet. You've changed 27 to the square root of 9 and the square root of 3, and this is multiplication. Okay, so can I simplify the square root of 9? Yes. What does it become? So it becomes 3.
Wait, what do you... The square root of 9 is 3.
Yes, so the square root of 9 becomes 3. Okay, when you simplify it, it becomes 3. Can I simplify
No.
3? Square root of 3. So no, so it's just going to essentially come down. So now I have 3 times the square root of 3. So then my answer to this in simplified form is 3 square roots of 3.
Callie, you know
Is there a way to check that?
every single.
You can always use your calculator to check it, yes.
Those are so
Yeah.
sweet. Tiny.
Yeah, your calculator will do that. Some of your calculators, some of the more advanced calculators will do this for you. Now here's the deal, okay, and I'm going to warn you now. Okay, one, on test, you have to use the yellow calculators, and we have one test over this, and they don't. Okay, number 2, when you get to Algebra 2, you have a test and a quiz over this without using a calculator. Okay, and number 3, there's a lot of times where you will not be able to use your calculator in pre-cal and other classes like that if you get that far. So you need to be careful. You need to make sure you learn these ways before you get excited about the calculator. But yes, you can do that with your calculator. Okay. Huh?
I didn't know what it meant at first.
Yeah. Yep, so you're good. So it's good that you calculator because then you can check it for sure. If you have a calculator that'll do that. Okay, let's look at another example. Now let me show you, before we do that, let me show you what the Algebra 2, how we do this in Algebra 2. In Algebra 2, it's essentially the same thing. We'll take the square root of 27 if that's our answer, and we'll say, okay, I know it's not a perfect square, so I have 9 times 3. So then I say, okay, basically it's the same thing as saying square root of 9 and the square root of 3. Well, the square root of 9 is, it comes out as 3. Whatever I cannot perfectly square out stays underneath the radical and multiplied together. Well, there's only one number, so it stays down there. So then essentially it's the same thing with just a little less work.
It's like GCF right there.
Okay? Yeah, kind of like GCF. All right, any questions on this? And that's, again, this is kind of a more elongated method to kind of, it's easier for some people if they have a hard time with factoring. This is also another method. This is what we use in Algebra 2. It's a little quicker. Yeah, I recommend the right one. Okay? All right, here we go. Let's look at this example. Let's say we have the square root of 240. What are the factors of 240?
There is a 1.
24 and 10. Factors of
Oh,
240.
oh, okay.
So I have square root of 240. I'm sorry, square root of 24. And square root of 10, thanks to Orion. Now, are either one of those perfect squares? No. Can I break down 24 more? To what? Square root of 2 and square root of
12.
12. Can I break down 2 anymore?
You could to 1.
No, yeah, 1 doesn't really make any difference, but so we're going to stay there. So I'm going to leave this, I'm going to circle it. Okay? Can I break down 12? Okay? Square root of 4, square root of 3. Can I break down 3 anymore?
No.
No, so I'm going to circle it, I'm done with it. Okay? What does 4 become?
2.
2. Can't do anything else with it, so I'm going to circle it. Go back up here to 10, because we haven't done anything with 10 yet.
5 and 2.
Okay? So square root of 5, Square root of 2. Can I do anything with those?
No, we're both done.
Okay. Now, the square root sign means they stay under the square root sign. Okay? If it's not a square root, it comes out. So right now, based on this, I have 2 square roots of, okay, 3. So this is 2 taken care of. You could put them in numerical order, but I want you to hold off on a second. Just put in 3 times 5. So notice how I put 3 times 5 because underneath there because they have radical signs. So I'm done with those. Now, I want you to listen very carefully. I have 2 more left. I know that, but I want you to listen carefully. I didn't tell first and second period this because they're not ready, and I don't know if they'll understand this without being confused. Some of them will, but not everybody. I didn't want to confuse an entire class. Then I told third period, and I still got people that were very confused. Just listen carefully. Okay? Whenever you break down all the factors, like we did here, if you have 2 that are the same, just take this number and put on the outside. Just take one of the numbers and put on the outside. So, I'm now going to have 2 times 2 square roots of 3 times 5. Now let me explain that again.
You don't need to.
Okay, first I do for some. 2 here comes from this 2 here that already came out from a long time ago. These 2 numbers, to make it a little more simpler, what is it? How do I rewrite square root of 2 times the square root of 2? How would I rewrite that? Huh? Square root of 2 squared, right? Because there's 2 of them. And we just talked about this a second ago, that the square root of 2 squared should be just 2, right? Because the 2 cancels and the square root sign cancels out. So that is where this 2 comes here. Okay, so that's why these 2 2's become this 1 2 without a radical. So everybody see that? So if you have 2 numbers that are the same underneath the radical, take the radical sign off and bring the 1 on the outside of the other radical. Okay? So then my answer becomes what? 4 square roots of 15. So you go ahead and simplify it all the way down, for those of you guys saying 3 times 5. Now, this is a seriously long way to do this. I didn't say wrong, I said long. And it's okay that you do this, and if this helps you, that's fine. Let me show you the better way. Yeah. Again, Algebra 2. And I'm going to refer to Algebra 2 a lot because that's your end game. Everybody has to take Algebra 2. Some of you will take it as seniors, others of you will take it as juniors. So everybody will take it, but I'm telling you this because you need to get to this point, and this is easy too. Had you picked the right factors from the beginning, this is a lot less work. A lot less work. Okay? Let me explain. If you take your chart here, and this is how I told my juniors to do this. Basically, you take this number 240, okay, and look on your perfect square side, not the square root side, the perfect square side, and go to the number closest to 240 without going over. What do you get?
Looks like 16 squared. 225. Without going over. 15.
Without going over. Sorry, 15 squared. 225, right? Now, common sense will kick into you at some point, hopefully. But what you start asking yourself is you start there at the very highest number and work up. Okay? So start with 225 and you say, okay, does 225 going to 240?
Yeah, one time.
Okay? Evenly. Sorry.
No.
Okay, anytime I ask you something like that, it's usually even. Okay, you're going to need a calculator for this, all of you that didn't get calculators, you're going to need a calculator for this.
Give me one. So
Okay?
spray it.
Because I don't want you guessing on these.
Spray it.
Eddie, can you bring me one?
Sprints, right?
Alright, so like I said, you start at 225 and you divide 225 into 240. 240 divided by 225.
240 divided by 225.
Does it go evenly?
No.
No. So then I work my way up the chart. Does 240 divide by 196?
No.
Huh?
No.
No. Okay, does 240 divide by 169? 240 divided by 144. You see, I'm working my way up the chart. 240 divided by 121.
No.
240 divided by 100.
Not possible.
No.
240 divided by 81.
Maybe. No.
240 divided by 64.
No.
240 divided by 49. 240 divided by 36. 240 divided by 25. 240 divided by 16. What do you get?
15.
15. So what are your factors of 240 using that number? 16 and 15. So you just worked your way up the chart to get square root of 16 times 15. What do you notice under there now? The square root of 16 is what? 4. So 4 comes out and you get 4 square roots of 15. So much more easy than this. Now, like I was saying, common sense kicks in. Realistically, you should have been like, and I said this 240 divided by 225. You should have been like, seriously? No way. So you could have skipped a whole bunch of numbers. Basically, I think when we were going through this, Gabe, he said to himself, when I got to 81, I think, he said, maybe. So maybe Gabe starts at 81 and goes 81, 64, 49, and so on. Okay, I just tell anybody that has a hard time with math reasoning, hey, pick the number closest to 240 that doesn't go over and work there. Once you hit one of those, you now have a perfect square you can work with. And not only do you have a perfect square you can work with, you have the biggest perfect square you can work with. Why is that important? The biggest perfect square you can work with, what does that do for me right away? Once I square root it out, what does it do for me? It was already what? Simplified. Because I took the biggest possible square root, or perfect square, and square rooted it, I'm already in simplified form. Here, I had to go down, and okay, 2 comes out. So that was out of that square root of 4, 2 comes out. Then I had square root of 2 times square root of 2, which became 2. So then that comes over here. So then I got to do 2 times 2 is 4. And then on the inside, I had square root of 5 and square root of 3. Then I got to multiply those two together and keep them under there. So there's a lot more work. This is already simplified for you. You don't even have to check it because you picked the biggest one. Okay, any questions on that? Okay, let's look at another example similar to that to give you a chance to practice that a little bit. Okay, on your own for just a second, square root of 660. Yes, and I don't want you to blurt out the answer when you're done. Square root of 660. Okay? If you work your way up the chart, what do you get? Okay, 4 times 165. So then my answer becomes 2 square roots of 165. Anybody disagree? Did anybody?
Solve it the other way, because I did it the other way and I didn't get that.
You didn't get that? I was about to ask if anybody did it the other way. Miserable. Okay. Why did you do it the other way? Because you don't have a chart?
Well, I do, I just
Shh. All right, here you go.
660.
Square root of 660, the long way.
2 and 330.
He said 2, square root of 2,
And 330.
and square root of 330.
So that's
Well,
number
that's
2.
done.
Yep, 330. I did 2 and 6, 165.
So 2, square root of 2, and
165.
square root of 165.
And I circled 2. And I wrote that one down.
Okay?
3
So then you got square root of 3 and square root of 55.
And then I did 5 and 11.
So you got square root of 5, square root of 11.
And then I said the 2 and the 2.
Okay, listen. This is good for everybody to hear. Okay? The 2 and the 2 do what?
Cancel.
Cancel and create what?
2.
Positive 2 on the outside.
Yeah. And then I did. Well, how come you didn't multiply it by 3?
Because 3 is underneath the radical sign.
Yeah, it's only 1, 3.
There's only 1, 3, so that's got to go underneath the radical sign. So times 5 times 11.
Oh, well, that's the only thing I did wrong. I put 2 on the outside.
Well, 2 is on the outside.
Put 3 on the
Oh.
outside.
So 3 times 5 is 15. To finish it off, 3 times 5 is 15. 15 times 6 is what? 165. But doing it Gabe's way, here's the deal too. How many of you guys, how many of you guys got this answer, but because you had such a big number there, you were kind of unsure of the answer? Okay? And thank you for being honest, because I know the other part of you are like, well, I just didn't care because it's just, no, it's whatever. But I don't know about you, but even as a math teacher, that makes me think, God, there's got to be something else that breaks this down a little bit more. Okay? But there's not. And thanks to Gabe's method, doing it this way, we can clearly see that nothing else breaks down. That is what it is. Okay? All right, any questions on that? All right, so let's move on. So that's your irrational. Now we're going to move on to adding and subtracting radicals. Okay? If you think about these like variables, and you follow the rules that you would have normally with variables, you're going to be in good shape. Okay, so here we go. So here's our next example. Let's say I have the square root of 9 square roots of 3 plus 3 square roots of 3. What does that equal? $12 square roots of 3. 12 square roots of 3. Because remember, if I treated it like a variable and it was 9x plus 3x, what would my answer be?
12x.
12x. So essentially the variable doesn't change, right? Same thing here. The square root did not change. Does everybody understand that? Okay. Let's look at another.
You should keep it the same, no matter what.
9 plus 3. What if I did 9 minus 3 square roots of 3? 9 square roots of 3 minus 3 square roots of 3. 6 square roots of 3, right? What if I have 9 square roots of 3 minus 3 square roots of 2?
You can't do anything.
Yeah, you cannot do anything. For you guys, right now, okay, you cannot do anything. So you just leave it as 9 square roots of 3 minus 3 square roots of 2. You cannot simplify it anymore for you guys at this point.
Can we
Okay.
just write simplified?
You can write simplified. Well, no, because technically it's not simplified. Okay, now, again, this would be like, for those of you who are confused, this would be like saying 9x minus 3y. We can't do anything else with that. 9x minus 3y is as low as it goes. Okay? So that's adding and subtracting. Let's multiply. Let's say I have 9 square roots of 3 times 3 square roots of 3. 27 27 was the easy part. What else? What?
The square root of 3 squared.
Which would be?
3.
No, square root of 3 is just, sorry. 3 squared is 9. You went a little more advanced than we needed to.
I thought it'd cancel out because you.
Hang on. Wait for it. You're a little up here. I need to be on everybody's equal level. Not just, never mind. Okay, so I end up with, essentially I'm multiplying 9 times 3, right? The two numbers in front. And then 3 times 3, right? So then I end up with 27 times square root of 9, which is 3 now, because we've got to simplify it. 27 times 3 is 81.
You didn't even say before this.
Okay? What if I have 9 square roots of 3 times 3 square roots of 2?
Can't do anything, so it just be 9 square roots of 3.
Wah, 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 wah. Can I multiply x times y? Can I multiply x times y?
Yep.
Yes. Can I subtract x times y?
No.
X minus y? No. Okay. So this is 27 square roots of 6. Can I simplify that anymore? No. That's the box. Again, all I did was multiply 9 times 3, 3 times 2, and put them in their respective places. And if I can simplify, I simplify. If not, I leave it. Okay. Any questions? All right, last example. That was multiplying, so now we're going to divide. So let's say I have 9 square roots of 3 divided by 3 square roots of 3. What's my answer? Say again? 3. 9 divided by 3 is 3. Square root of 3 over square root of 3 is? It cancels out, right? Or 1. Okay? How about 9 square roots of 6 divided by 3 square roots of I don't know.
25.
2.
It would just be 3. 3 square roots of 3.
3 square roots of 3.
That's not 3.
No. 3 square roots of 3 is 3 square roots of 3. Okay? Anytime you can simplify, simplify. Okay? Because if I had square root of 12 divided by the square root of 3, then I would end up with what?
Say it again, dude.
Okay, look. Square root of... Not that. Okay, hang on. Don't put anything away because you got one more example. It's a little more difficult. Okay, square root of 12, part of this. I'm not... Really? Shh. This is still part of 8. Square root of 12 divided by square root of 4. I'm sorry. Square root of 12 divided by square root of 3. What do I end up with? Square root of 4, which is 2. Now, still division. Let's say you have this. Square root of 144 divided by 36. Okay.
Then it would be 2.
We can do it two ways. You could do 144 divided by 36, which is what?
Could you break it down and say square
Hang
root
on,
of
hang on,
144?
hang on. 4, right? So 144 divided by 36 is square root of 4. Square root of 4 is 2. Now, here's the deal. This is not the way we want to do this. This is what a lot of you will do, and this is great if it's easy and it works out perfect. But what you really want to do is take this 144 over 36 and make it square root of 144 over square root of 36, which makes it 12 over 6, which is 2 as well. And you might think to yourself, well, that's more work. Yes, it is more work, but that's because when you get to Algebra 2, you may have this problem right here. Square root of, let's just say 14 over 36. Okay, I could reduce that, but is 14 going to 36? No. So then you say, okay, square root of 14 over square root of 36. Well, square root of 14 over 6. And that's my answer. And that's an irrational solution, and that's why you need to know how to do this method. Okay? On your way out, your homework is on the table. Grab both of them. They're both due tomorrow.